Hello there. So today I'm going to be talking about my final exam, problem one for operations research. And yeah, I'll just get right into it. So we were tasked with designing a business problem where we had to use network optimization to solve some sort of real life problem that we devised ourselves. Um, what I decided to do was do a network optimization problem about Engineering Test Kitchen, which is a club on WashU's campus that I co-lead. And as president, I recruited different officers to fulfill certain positions within the club, and they're responsible for doing all sorts of activities like, sending emails, setting up meetings, conducting meetings, setting goals, getting funding, all sorts of generic things that a club would be doing. And the goal of Engineering Test Kitchen is to, it acts as a consulting firm where it matches WashU students with projects that are either found in St. Louis that we work for companies, like we've worked for Eaton Bussman before. We've done stuff with the St. Louis Zoo. And we've also done different things with WashU departments. So we've done stuff with the med school. We've done stuff with the Sam Fox Art School and Design. So mostly our team is made up of officers or, executive team members who are in charge of getting these projects, matching students to the projects, and making sure that the students fulfill those projects. So that's kind of what we're about. And you can see the executive team members, and you can see all of us working. And these will be our main characters for the project. So the executive positions and corresponding people, so like the two presidents and each person for each job will be the nodes for the Mind Network. And the arcs are formed when one officer sends a job to another. That's kind of how I decided to think of it as. And then when I explained kind of what the jobs are, securing a budget, meeting with a project client, all sorts of things. In the real world, the networks are limited by cost, but because there's no money flowing between us, I decided to use time as like hours per time working on a job. So how quickly it takes each officer to finish a job. So you can see down here, each of the officers have nodes where we have a president PML, a president PGM, and those just come from the names and the title of the position. Arcs, which are different forms of communication to show the jobs. The flow are the jobs that are exchanged between officers. And then finally cost, or in this case time, which is the number of hours spent on a job. And these I just kind of like randomly picked how long it takes each person to do a job. It was not really personal to any one of the officers, which makes this more of a made up problem. And so the decision variables, we have X, I, J denotes the amount of project from I to J. And we have a decision variable that represents each arc, each movement from node to node between each officer. And so there are some constraints that I wanted to follow, which is the supply nodes, which are the presidents who come up with the jobs. The total flow out of them is the total output of the supply node. The total flow into a demand node, which are the operations leads, who are the people that ended up receiving all the jobs at the end to finalize the project. And that is the total flow in. It equals the allocation of jobs to the demand node. The total jobs put into transshipment, those are the nodes in between. So the in-between men who also ship jobs from the presidents to the operations leads. And those are sent to the sinks, and those have to be equal. And then nobody can do negative jobs. So the goal is to minimize the total time spent so that we can set up a project quickly and efficiently. And we want to sort of make sure that we can set up projects in a reasonable time period. So we're trying to optimize how many jobs we can get done in the shortest amount of time. And so here's kind of part B shows sort of a visual representation of what's going on. So we have the two sources, which are the two presidents giving jobs. The transshipment are the VPs, the recruiting, the treasurer, and the sinks are the operations leads who take in all the jobs at the end. And then more specifically, I have values in to use this problem as a minimum cost flow chart or network. And we see that there are 30 jobs that we're going to start with, 15 plus 15, and then there are 30 jobs that we're going to end with, this -8 and -22. So that's kind of formatting our network, how many jobs can be put on each arc, how many jobs each person can do between the two. And those were just kind of arbitrary numbers that I picked to do this network optimization. All right, so from that, I was able to write an equation, a minimization equation, a minimization LP, where we have a certain, for each arc, we have our decision variables that have the attached costs or time spent per job. And we have the maximum number of jobs under the constraints, and also managing the inflow and outflow of each transshipment node as well. So this is what these 5, 6, 7, and 8, the constraints 5, 6, 7, and 8 are for. And then we also want to make sure that nobody's doing less than 0 jobs, and we don't want anybody doing more than 20 because that would be a lot of jobs for one person. And so yeah, so I initially proposed a minimum cost flow solution where I went from the president to the VP to the treasurer to one of the operations leads, and that gave us 10 jobs, and that took us 6.75 hours. Now that's just the starting value, but once I used MATLAB, I was able to find that we could actually do 30 jobs in 48.75 hours, which is pretty cool. So then I could see also, okay, which officer am I going to assign? So there are going to be 15 jobs that go through PML, 15 jobs that go through PGM, 10 jobs that go through VPSE, and another 20 that go through VPSE to TCO, and then so on and so forth. So the way that this works out, you can kind of see how the numbers are, how the jobs are moving through the network. You can see that actually VPKG did not get assigned anything. So it's the only officer that does not have jobs, and that could be because of the time per job that it takes to do the VPKG versus the VPSE. It could be just because maybe we only need one VP, not two. So an interesting sort of a discovery with that. But for the MATLAB code, it looks like this. I used the optimization toolbox, and ultimately I wrote 2 different codes where I did int linear program was the main command that I used, and that sort of gave me the optimal objective value, as well as you know, which jobs would be, what number of jobs would be assigned where, so down here. So that's what I got from MATLAB. And then going back to this, the next part was to do some sensitivity analysis. And for this, I used the IBM Optimization Studio. And with that, if we go into that, you can see I was able to set up my own minimization LP. And then from there, I could run a few programs, export that LP, use the interactive optimizer over here, and I could tell it to read my file, and I could tell it to display my sensitivity right-hand side. So I could see the ranges of the B for the right-hand side over here, as well as I could see the ranges for C for my objective function. So that's kind of summarized over in these 2 tables. You can see the range on each number of jobs that a person that can be completed, and also a range on the cost, not the cost, the time spent on each job. So what I learned from this was mainly 2 things, which is that the number of jobs passed can be estimated more closely because small changes in those could result in changing my optimal solution and changing the amount of time overall that's spent. I also saw that a 10% decrease in time spent on a job would affect a quarter of our officers, and it would affect our optimal solution greatly. As you can see, it's highlighted above. Those are the time spent that I chose per job, just the arbitrary time spent. But if that value decreased, we would have a serious change in the optimal solution and the amount of time that we could get our project done. The same thing if we had an increase, a 10% increase. You can see that highlighted in blue here. For half of our officers, if we increase the amount of time that they spent on a job, it would greatly increase our optimal solution, which does make sense. And yeah, so we should place more time, I think, into estimating what these values are for how long it takes a person to complete a job. And this doesn't even take into account like that each job maybe has a different time spent on doing it. So that is a different layers that I did not attempt to, that I sort of simplified and did not attempt to go into for this project. But yeah, I think it was a really great project, and I enjoyed learning more about an organization that I'm already involved in. And as a manager of that organization, it always taught me something new about my workflow. And yeah.